Thanks, Beth, and thanks very much for the invitation to talk. I have to say it's the first thing that got penciled in my diary when Beth was organising this event, and it's the one thing that I refused to shift for anything else. I really wanted to be here and be part of this and talk to you today. And as Beth said, it's a talk that I've given at a few different universities, Reading, Liverpool, York and Oxford so far. And it's about particularly representation of LGBT scientists, my own personal journey as an LGBT scientist. And it's a pretty difficult talk to give because we don't often stand up as scientists and talk about, firstly, LGBT issues and secondly, ourselves to some extent. And so the theme of this talk, and I'll come back to it at the very end, is this quote, "No sexuality, please, we're scientists." And I'll talk a bit about where that quote comes from at the end. So I'll start by reflecting on my own educational environment. This was where I grew up in South Manchester. This was my state school. This was my friends in it. You won't see me in this picture because there's no way I'm showing you me age 15 years old. Right? That's not happening. But you can see a lot of diversity in this picture amongst my friends, right? There's a lot of evident diversity. There's women and there's men, and there's a Chinese student from Sri Lanka, student from India, all two born outside the UK, one born in the UK. But there's also diversity that you can't see in this image. So, for example, I only found out many years later that one of the people in this picture is bisexual. Okay, you can't see that in the image. Sadly, it was never the person of these five that I wished was bisexual. I won't point out which one that was. But there was a lot of diversity there. But the diversity you don't see is the sexuality diversity, in essence. And that's going to be a key theme of what I talk about today. This idea of sexuality as very often being a hidden diversity. And I was at school in the 1980s, of course, when Section 28 was prevalent, and so there was a teacher in the school who was well known to be gay, the French master, and he got verbal abuse in the corridors. People would shout down the corridors after him, asking him whether he'd got AIDS yet, was he going to die soon, and this was open and never challenged by other members of staff. Interestingly, I again only found out many years later that his partner, who was not known to be gay in the school environment, was one of the most popular chemistry teachers in the school. Taught me my GCSE, taught me my A-level, but nobody knew within the school environment that he was gay. Would his life of a teacher have been very different if the students had known? It probably would, because his partner, the French master, had a really terrible time from the students. This was a difficult time growing up, and there were really very few as effective role models in that period. So when I became a professional scientist, I thought, well, it's interesting, and sort of came out as gay. I wanted to look around and see what other LGBT scientists there were. I sort of started doing this 4 or 5 years ago, and so I did effectively what all my students would do, which is I looked on Wikipedia to see if there was an answer to this question. It's what all our students do. And there was a list, which was quite encouraging, really, that LGBT scientists from the United Kingdom were listed, and there were set names, and I thought, it's really good. You know, there's some good role models here. So I examined this in a little bit more detail. All of these ones were dead. That's not to say they're not important, but they're not around anymore. Of course, some very well celebrated by both LGBT and scientific communities, such as Alan Turing. One was dead and was never a scientist in any sense that I could work out, though journalism is a science. John Wells was retired fully. Simon LeVay is very significant, semi-retired, he's in his 80s, lives in California, did a lot of research into the psychology of homosexuality, but is also semi-retired. One was Evan Davis, who was working on the Today programme at the time. He's a scientist because apparently he studied economics. And economics is a science, according to this listing. Quite a lot of these people were economists, actually. John Maynard Keynes is another good example of an economist. And that left us with one, Sophie Wilson. And Sophie Wilson is a living scientist. She's a transgender scientist, and she developed the ARM system of computational programming, effectively, that sits inside pretty much all modern microprocessors inside computers. She developed that working with Acorn in the 1980s and is still working in computational science. So of all this list, there was one living UK LGBT scientist, which I didn't think was probably correct. So I thought I'd look elsewhere for LGBT scientists and scientists in general. And so I did a thought experiment, which turned out to be quite interesting. Did this in 2013, as you can see. I looked at the top 100 people listed by Time magazine. Every year they list the 100 most influential people in the world. And then I looked at the top 100 LGBT plus people that were recognised by the pink list of the Independent newspaper. So there's a lot of data on the next slide, because I'm a scientist and I like presenting data. But to pull out the key points, if you look at the top 100 people in the world according to Time magazine, lots of them work in politics and business, as you might expect, about half of them, very influential. About 10 of them work in science and technology, specific jobs, 30% or so in arts and the media, 10% in the sports, and the remaining 10% were weird collection of things from chefs to members of royal families, right? Then if you look at the independent pink list, who's recognised by the LGBT community as being significant, there were lots of people who were activists more than politicians. You'd expect that for the LGBT community that has less recognition in mainstream politics still. There was a huge representation of arts and the media amongst this list of LGBT people. That was the vast majority, really. Sport was very well represented. It's often been stated that there aren't very many LGBT plus sportsmen, and clearly gaining role models amongst LGBT sports people has been seen as important by the community. But science was effectively unrepresented. I mean, I counted this as one person. It was Evan Davis again, and it was a psychologist who was working in psychology, which was, I counted as a proper scientist. And that was the representation of science in the list. And I think the LGBT community has often not looked at science particularly seriously, and I think scientists have often not represented or discussed their personal lives, and I think that's partly what lies at the heart of this lack of representation. It's a two-way process, I think. And so I made a little video about that on YouTube, and I sort of asked about LGBT scientists, where were they, you know, I assumed they were there. I knew people who were LGBT and who were scientists, but it wasn't evident who those people were necessarily. And so I made a video about that. And around a similar time, Tom Welton, who many of you may know, who works at Imperial College London and is a gay scientist and a chemist, he was head of department, he's now at dean level in Imperial College London, wrote an article for The Guardian looking at similar things, and he said gay scientists are almost completely invisible. And he also noted part of the blame for this lay with the LGBT community. He looked as much at the LGBT community being not interested in science broadly as he did at the scientific community for not engaging with LGBT issues. So there was my video and there was Tom's article, all at a similar period, and if you open this discussion, these are the kind of comments that you get back, either on the webpage of The Guardian or on your video. Your mistaken is for people who give a shit, your sexuality is not important vis-a-vis your job. So your fellow scientists don't give a shite about your sexuality, just your research credentials and publication records isn't that equality. And that's a very, very prevalent view. If you talk about being an LGBT plus scientist, this is what people will say. And this, you can view this as complete meritocracy, and I think science is pretty meritocratic. You are often judged on what you produce and what you do and what your research is, and I hope we're going to see some brilliant research later on today that will show that. But it's also a kind of don't ask, don't tell attitude amongst scientists. I think broadly speaking, the scientific community simply doesn't want to know about this issue. Would rather not discuss it. I think that goes wider than just LGBT issues. I think that extends to personal life in general. You know, childcare responsibilities that people might have in the workplace. I think a lot of scientists sort of don't care, put in the hours, do the research. I think there's a broad view that you've got science here and your personal life sits here and it's not relevant. And so this then discussion has spread to America, and Manil Suri wrote a really nice piece in the New York Times asking why science is so straight. And he said he brought this up with colleagues and discussed this And he noted that when he did that, it was a very chilly reception, and in the article he says he'd violated an unspoken convention of STEM, and that is the invisibility of its LGBT members. And he felt that it was fine, wherever it was don't ask, don't tell, but scientists didn't want to openly discuss this. It's a great article. And there are issues and problems with this, and I think particularly they affect young scientists, and it's good to see lots of young scientists here as well. And this is very much the life of a young scientist, actually. Here's the young scientist, and her boss says, you can have two choices, Tajil. You can switch to a different professor and start your thesis all over again, or you can leave everything behind, move across the country, join me in my new research group. And she's kind of worried this is going to mess up her life, right? And this is the response of science generally. Okay. What's it going to be? And this is the life of a lot of young scientists. They have an advisor that they're totally dependent on, their thesis advisor, their postdoctoral supervisor. It wholly depends on the attitude of this individual, what this person's chances of success are. And that's the worry that a lot of young scientists have, that if they're in an out environment with their supervisor, if the supervisor has a bias against that, even an unspoken bias, the reference letters that this person receives will not be as fulsome. And it's well known, for example, if you look at reference letters that women receive and reference letters that men receive, they're hugely different due to unconscious bias. The words that are used about women and men are very different, and people worry that the same thing would apply if they declare their LGBT status, that this would change the way in which they're recommended by their supervisor. It's worth me stating at this point, I didn't come out as an LGBT scientist until I had an academic job. When I was a young scientist, I didn't feel comfortable in this scenario taking my boyfriend along to parties that my supervisor might be organising. I'd just say, oh no, I don't have anyone to bring along to this event. And since I've been talking about this issue, I get quite a lot of emails on it from all over the world actually, and they say all kinds of different things, and I'm going to share a few of them with you without any names, obviously. And this is typical of what young scientists say. At what point did you first come out? Did you come out to your supervisors? I'm thinking about coming out to lab mates and maybe my supervisor, but I'm not sure about it. And a lot of people worry there'll be unconscious bias against them in job hunting. This should be something we're happy to discuss as scientists. It should just be a part of life. And because of this culture, a good friend of mine, Adam Smith, who was working at the time for Research Fortnight magazine, wrote a very nice piece, LGBT academics aim to wipe out this don't ask, don't tell culture, that discusses quite a lot of these issues. This was from May 2014, and there's a few people here who contributed to this article with some very nice kind of vox pops that ended up in there. So for example, Matthew said from here at the University of Sheffield, a junior researcher's relationship with their supervisor is crucial. The supervisor can have a lot of influence on their prospects. Many researchers think it's necessary to avoid personal details. If you can't even have a conversation with a colleague about who you spent the weekend with, it's not a nice working environment. And if you're not in a nice working environment, you'll probably go somewhere else and find a different working environment, ultimately. And another researcher recalled, this is from the same article, that as a postdoc she heard a senior colleague mock a former teammate for having been gay. And as a gay woman who had deep respect for the scientist, she said it really affected her. She told the colleague his words could insult all gay people but didn't take it further. And as I was developing as a younger scientist when I wasn't out, I heard mainly anti-gay jokes in coffee room environments, down the pub when people had left work, both from colleagues at my level and from senior colleagues as well. And that was reasonably prevalent. I think society's changing, so I think some of these problems naturally are disappearing to some extent. And I am going to not only talk about issues, I'm going to try and look at solutions and strategies to some of these things as we get later on in the talk. So there's a really nice survey done in the States from Jeremy Yoder. I'm not going to talk much about it because I think Elena will also mention it this afternoon. But it looked at the outness of scientists and engineers working in the US, and it asked them how out they were to friends and family, and a lot of them were very out. How out they were to colleagues, and it was a very different distribution. There was a certain number who remained out, but then the rest of the distribution tailed the opposite way. And to students, if they were working in a university environment. And again, a sort of core who are just out, about a quarter, but the remainder sort of often very less out. And he looked at reasons why this might be, whether there were institutional reasons that might affect this. And so in particular, he looked at, is your workplace welcoming? And he found that if the workplace was viewed as welcoming, then generally speaking, those scientists were on the more out end of the spectrum. If their scientists felt they were treated the same in the workplace, they were still towards the more out end. If they had a hostile workplace, the scientists were less out. And the really interesting thing was those scientists where they were unsure about the nature of their workplace. They were right down at the not being out end. And this demonstrates that it's important for institutions and departments to signal something to LGBT plus staff members. If they don't make a signal and people are not sure, then generally speaking, the majority of people will not declare sexuality and will decide not to be out at work. And this is by doing nothing negative, but nothing positive. And we are going to talk a bit later about what institutions and departments can do. So this is another typical email comment I got from a student at a major UK metropolitan university where you would think the culture might be very different, and they just email me this, except for rumour they have no LGBT staff or students, and they find it a very isolating environment. This was from a university that at first sight you would think I'd choose to go there if I was an LGBT student. You'd think it would be a good place to go. And this is chemistry specific or physical science specific perhaps as well, but throughout my academic life in chemistry, and again this is somebody who contacted me by email and we discussed on the phone a few times, I found that chemistry has a very conservative macho culture, and again they use the words don't ask, don't tell policy. Any sexuality related issues are met with embarrassment or hostility, more so than other academic areas I think, unless you're straight. And they notice it doesn't help on an emotional level. It can leave you feeling that you're the odd one out, and perhaps leading to giving up on a science career because of feeling isolated. And so, in a way, this is what's important about this kind of meeting as well. One of the reasons I'm so happy Beth organised it. And it's worth just reflecting globally. This was said to me in, well, numerous comments really, that science has no problem with LGBT, you're making a fuss about nothing, why are you worrying about any of this? I find this quite complacent. Also, we should think globally as scientists, and it's important to remember that, you know, many of the sort of northern areas of the world are pretty good with regard to LGBT rights, at least on paper. And South America's good, and Australia's good, of course Sub-Saharan Africa, Africa and generally the Middle East, India, there's still lots of legislative problems for LGBT people. And perhaps one of the reasons that science is then fairly complacent about the issue is if you look at where the science is done in the world and plot that on a map, this is the world with respect to where the science is done. It's broadly done in bits of the world that have relatively progressive policies on LGBT marriage, LGBT rights in the workplace and so on. And as scientists, we tend to overlook many other parts of the world where there are huge problems. So, you know, if you're collaborating with a scientist based in Saudi Arabia or Kenya, or you've got to go and give a research lecture in India or Russia, or work with groups over there, or send your students over there for placements, it's a very different environment that they're going to be going into. And we have to remember that, even though it's a smaller part of the scientific world in general. We can't just overlook it and say, well, it's all okay in the UK and the US and Europe, the rights are in place. And this is another email correspondence that kind of illustrates that. I'm a gay university lecturer in Kenya, homosexuality is illegal, I'm still in the closet, it's very difficult meeting like-minded scholars. I've never heard about gay professors in academia, I am so lonely. I've wanted to promote academic fellowship, and it can lend much needed solidarity, particularly in developing countries. I'm humbly requesting if we can exchange experiences and share ideas about gay scholars. Surprisingly, you know, this really surprised me, you're the first gay professor I've heard about, and so on. So this is a real issue for people, particularly in environments like this. So it's worth talking a bit about my working environment now and beginning to think about perhaps solutions to some of those issues in a way, or how I've approached some of those issues through what I've done, and then more general solutions later on, and general strategies we can think about employing to overcome some of those problems. This is the Department of Chemistry at York, research buildings, we have teaching buildings, and my job, of course, as an academic is 50-50 between the two, really, and my office is up here. Unfortunately, it's hidden behind a tree, so you can't see the paperwork piled sky high in the windows, for any of you that have ever been in my office. And one of the stories I always tell about my research, and I put this into my research lectures, is this one. And so this slide has appeared in all my research lectures now for about 5-6 years. And I always, it's motivated quite a bit of our research. So I'm in a fortunate position that I can tell a story about why we do the research we do. And I always start by saying, you can see from this picture of my civil partnership ceremony that I'm gay, and the primary reason for that is purple shoes. And I tell various stories about this and what you can see in the picture, but what you can't see in the picture is that my partner looks perfectly normal, in inverted commas, but what you can't see is that he has a severe lung disease, cystic fibrosis. And it leads to lung damage, and quite a bit of our recent research has focused around or looked at solutions to issues that might be faced by patients with cystic fibrosis. We've tried to apply my science in this area. And so in 2010, Sam's lung function fell to about 20% of normal. It's been declining for many, many years. Of course, cystic fibrosis gives you a life expectancy in the late 30s. He had this declining lung function for many years, and ultimately he got to the stage where he was on oxygen 24 hours a day and needed transplantation, which was done up at the University of Newcastle. And this is probably the best selfie that I've seen. This is one day after a double lung transplant, this picture. And as a chemist, it was a really stimulating environment to go into, right? Because, I mean, firstly, I was kind of glad he was alive. You know, it's important to state that first of all. But then you're looking at all these things. You know, there's the oxygen, and you can read all the oxygen pressures off this little bleeping machine, and there's the heart monitor, and you can follow all that. There's a neckline going in here, and all of these things are running into the neckline, and this is loads of different drugs. Quite a lot of interesting chemistry is being pumped directly into the patient a day after transplant. And yeah, he's pretty grumpy because I spend a lot of time talking to the doctors about all these drugs and working out what they all were and so on. So this is the story that I always tell about my research, and this kind of inspired a project in my lab because there's a key drug that's used during surgery, which is heparin. And heparin is a negatively charged biopolymer, and it's used as an anticoagulant during surgery. So when you're doing surgery, you cut people open and you want to reconnect bits, what you do is you snip bits out of the veins, then you put clamps on either end, and then you do your stuff, and then you want to reconnect those veins and arteries, and then you take the clamps off, and you want the blood to flow again. If it's formed a clot where you've clamped stuff, then that's no good. So you need an anticoagulant during surgery. Pretty important. Once the patient goes back to the ward, you need an antidote. Because if the patient isn't clotting, then they can't recover. And if as a surgeon you've made a little mistake, then the patient will bleed out when they go back to the ward because their blood isn't coagulating properly. Right? And surgeons are very worried about this because it makes them look bad, primarily. I mean, it's not very good for the patients, of course, as well, but surgeons don't want to look like they've not done a proper job. So the agent that's used clinically is this protamine sulfate, and that's one of the things that was going in Sam's neckline. And I talk to doctors about this because there's quite a lot of problems with this drug. About 10% of patients have a very adverse response to it. 3% of patients have anaphylactic shock. The doctors can't give the dosages that they want of this to remove all the heparin, and very often then patients struggle with anticoagulation about 12 hours after going on to the ward because the doctors had to be quite conservative using this drug. And so they quite like alternatives to this. And in our lab, we had a whole load of molecules that could bind to things like heparin, because what my research is about, fundamentally, is how do you make one molecule interact with another molecule. That's what I'd specialised in for 20 years. And so thinking about heparin as a target, thinking about how to design things that could bind to it, we actually had things sat on the shelf in our lab that could do this job. So I was sat at Sam's bedside, hoping that he recovered as quickly as possible so that I could get back and tell my group what they needed to do next. and the obvious as well. But, and so we took an approach, which is obviously looking at molecules as a chemist. We had this kind of molecule lying around to walk you through what the bits do, because I know you're not chemists. It's designed with a bit here that binds to heparin, a bit here that encourages it to assemble into a nanostructure, and then you get this nanostructure with a surface that wants to bind to heparin really nicely. And you can model this in computers, and you can see this nanostructure bound to heparin. And we've designed it to have degradable bits here so that you can use plenty of this, dump it into a patient in principle, and the excess will simply degrade and fall apart over time and not have any toxicity effects in the patient, whereas the stuff that binds to the heparin remains nice and stable and can be excreted by the patient. And we've done studies on this, and it kind of works. If you take plasma, it clots in 13 seconds. If you add your heparin, your anticoagulant, it doesn't clot anymore. If you then add our rescue agent, the plasma clots in 13 seconds again. And we're in the process of trying to translate this approach out into the clinic. We've now modified the chemistry that I've shown you here to try and improve some of the other properties to make this work even better. And we published this, and quite nicely, my husband's name is Sam, we managed to coin some new terminology, because this is a self-assembled multivalent binder, so we could call that Samuel. We weren't allowed to call it Sam, because that's something else in chemistry, that's a self-assembled monolayer. So I had to put the UL bit in, and of course it's not quite the way he spells his name, but it's not bad. And so I tell this story when I go to research conferences. It's a part of our research profile. And if you do this kind of thing, and because I could tell this really very personal story about the research that we're doing, that means the press is quite interested in this. So Sam was absolutely horrified to appear on page 3 of the York Press and have people coming up, waving it, going, I think I've seen your picture in the paper, and he wasn't very impressed. It got written up as a kind of piece in Science by a journalist, Sharon Ann Holgate, about this sort of how I'd been inspired by this. This got nominated for a journalism prize last year. She did a beautiful job writing this up, actually. And Science Careers focused on this as well as a sort of alternative insight into careers for scientists, which was nice. And I do a lot of outreach, as Beth mentioned, and so I talk about the context of our research in outreach. I go and talk a lot to members of the general public. I go and talk a lot to school students, especially aged 16 to 18, about chemistry research, and this is just a part of that talk. You know, it might be a 40-minute talk, and that story, pretty much that 8-minute snippet that I gave you, might be there as a 8 to 10-minute snippet of my school's lecture with a bit of a demonstration in there as well. And the fact that it was done because of my husband's influence is just thrown in as a side story to kind of snare the interest of the audience, really. And I also, as Beth said, have got a YouTube channel where I've looked at both straight chemistry issues, like why Brian Cox is not a chemist, and his TV shows are full of chemistry mistakes, through to things like what is the chemistry behind HIV treatments and potentially cures, question mark, and looking at things like illegal drugs, which is how you get 500,000 views on a YouTube channel. So they're the kind of things that I've done, I suppose, that have kind of just broken down that barrier a little bit between my personal life and my scientific life. And I've been comfortable doing that, but I'm in a lucky position that my research, all those stories are true. That's why we did do that piece of research, so I just tell that. Now, I also am really lucky to work in a good environment in terms of diversity, with chemistry at York having the Athenas 1 Gold Award and having been very forwards thinking about a whole range of diversity issues, which means it's an environment that's very easy to talk about these kind of issues in. Now, with regard to LGBT students within the department, I wanted to highlight this guy, Tim Bradbury. He likes this picture because it's taken when he was 21, and he's not anymore. He's like 30-something. He's a teacher now, head of science in a school in Whitehaven in Cumbria. And he was one of our undergraduates in 2005. He contacted the head of department to say there's gossip in the department about Dave Smith, it's homophobic in nature, and it's making some of us very uncomfortable. Now, at the time I wasn't out in the workplace at all, and the head of department came to see me and said, there's some terrible gossip about you in the department, and you might want to do something about it. I said, what is it? You know, think, God, it must be awful. He said, well, people are saying that you're gay. I said, well, I am. And it's not so terrible, but the way some of the gossip was being stated, of course, when these things are hidden, and of course LGBT is always or very often a hidden diversity issue, then the gossip that surrounds that does become negative very often. And so I decided this was something that probably needed tackling a little bit more in a head-on way with our undergraduate body. There's a nice study from Engineering Studies Journal from 2010, actually, where they looked at a major US university and they looked at a group of LGBT students within that university and looked at their experiences and worked very closely with a group of students. And they found that pervasive, prejudicial cultural norms and perceptions of competence, blah, 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 limit these students' opportunities to succeed relative to heterosexual peers. They developed coping strategies to cope with a chilly, heteronormative engineering climate. And generally speaking, many of these students tried to pass as heterosexual, cover or downplay cultural characteristics associated with LGBT identities. Exactly the same things I'd done as an undergraduate student at the University of Oxford many years before. And this was often accompanied by academic and social isolation, making engineering school a hostile place for many LGBT identifying students. So I wanted to try and change that for our students and then find out what they experienced. So in my very first lecture I give to our organic chemists at York, I talk about all the exciting research going on in the department to try and inspire them. It's the one chance you have fresh faces that you can inspire. They've not been ground down by 50 lectures from my colleagues by that point. And me, I hasten to add, looking at some of my colleagues in the audience. And I just drop in on one slide. We do some research, and one of the things we do is gene delivery because of our interest in cystic fibrosis. It's another polyanion. DNA is also negatively charged, just like heparin, and so we also make systems that aim to take it into cells and try and treat cystic fibrosis. And I just throw that in and mention my partner. It's not a big deal, but they know that it's just something that can be discussed, really, and it's not an issue, and I don't expect them to find it an issue. So having done that for many years, I then did a survey, rather like the one done in that engineering studies article, about our department and the environment of it for LGBT students, whether they found it a safe and supportive environment, if they had a specific issue to discuss. And the way I organised this was kind of very informal. One of our undergraduate reps, who was out and LGBT, I passed this document on to, and they circulated it amongst LGBT people that they knew in the department, and then they collected those responses back anonymously, and then through that filter the responses came back to me. And so we got a survey of students who identified as LGBT and were out in this particular example. And so it was an effective virtual focus group, and it was actually organised by Robin, who is sat in the audience here and is one of our graduate students now. And these were some of the key comments that came back, that students found it important to see there are people like us who make it higher up, both PhD students, it was people in teaching lab environments and academic staff. In my opinion, it's the same as anything in society. You see influential individuals in positions, role models, etc., etc. And this was nice to see, having LGBT role models help my own coming out process. And actually, we found in recent years that a number of students have come forwards and discussed with me or other people in the department issues they may have been having surrounding being LGBT. So the department put this into the newsletter to disseminate results across the wider body of the department that noted primarily it was felt to be a safe and supportive space for LGBT students. And the wider student media picked up on this as well, mainly because I had a good contact who worked at the time for the student media. She now works at the Mirror down in London, so she's gone down in her journalistic integrity since the heady days of York Vision. And she ran a very nice piece as well, so that disseminated across campus. As a result of this, the university then decided to run a similar survey of students across the whole of the university and look at the experience of LGBT students. So this began to influence more broadly the institution. And we embedded this within the departmental ethos, so on our web pages we have a specific LGBT page, it has results of the survey, it has links out to useful pages that students would find useful. We also have a listing of all the members of staff in the department, both LGBT and not, who have declared themselves as happy to talk to students about LGBT issues. The fact that that is embedded is partly shown through by, for example, this group of students. This was their attitude picture that got them into the gay press. It's not exactly the same as the group of students who went to the games. But it was organised by Chris Unsworth, who is a chemistry year 2 PhD student. He's also here in the audience today. He organised this group of students to go to the LGBT Euro Games in Stockholm, the first university that had ever sent a group of students. He did extensive fundraising for that across the Department of Chemistry at York and across all of these departments more widely. And I think it was simply fully supported. It wasn't questioned that the university and the departments were going to support this kind of activity, basically. Which I hope, at least, is a good environment for these people, and that comes all the way down to first-year chemistry undergraduate students. And again, this was a nice comment from one of our students, that having it not as a hidden aspect of diversity in a way, having it as a partially visible diversity aspect, made them feel a lot better in first year, having come from a school where LGBTQ welfare was swept under the carpet and there were no out students or teachers, or next to no students or teachers. And as I said, that's linked up to institutional level, so it's good to see things changing in the institution as well. Our new Vice-Chancellor, for the first time, raised the rainbow flag for Pride Week this week. That had never been done before on campus by someone at the very top of the institution, and that flew through Gay History Month in the middle of campus. What can we do as individual scientists? That are very simple steps. There's no clock in here, so I'm just a little bit...
You've got about 10 minutes.
Perfect. That's all we're working on. Right. What can individual scientists do? Well, this is now my standard biography that goes everywhere. I'm collecting data on how many conferences that I apply to with this standard biography. Cut this bit off from the bottom line, the bit that's underlined, the personal life bit. I like biographies that have a statement about personal life. I think it's a good thing to do personally. I know there's different opinions on it, but I think this on my website, obviously, it's a very easy way of stating things. Even if you're not in civil partnerships or married, you can say is part of an LGBT diversity group or whatever it might be. I think it's good for people who have family responsibilities to note that, that you can combine a family with science. There's lots of people, particularly women in science, young women in science, who struggle with that concept. Don't see many role models who do that successfully. And so I like the idea of a small amount of personal life on biography. I've always tweeted, it's how I know Beth, I guess, for a number of years, and this is a very kind of low impact way of just being yourself to some extent. I use Twitter kind of professionally and personally, and a bit of a mix and a mess really of my Twitter. And if you did a Wordle based on my Twitter account, this was done a year ago, you'll see I'm quite enthusiastic, great, good, you know me, you'd be surprised by that. Chemistry, of course, features big, and York, and people, and gay features quite big on my list of things as well. And of course, Twitter is an open forum. Anybody can interrogate this. It could be the next person you're going to visit on the other side of the world. It could be the students that are sat in your lecture. It could be your colleagues. And yeah, that's also caused problems from time to time with various things that I've tweeted, but that's a story for a different seminar. And you can share all kinds of things. So most recently, anyone who's followed me will have seen lots of sharing about adoption. This is the little boy that we adopted just over a year ago down at the beach in Cornwall. So what can departments and institutions do at the sort of bigger level to change things? I think any of you that want to take one document back to your departments, if you want things to change, or to your institutions, it's this one, available on the web. It's an outstanding document about how, it says it's physicists, but it applies to anybody working in a STEM setting. It's a best practices guide for departments, and it has lots of sensible suggestions in it. If you work through it as a checklist, it would be really, you'd be in a great place. And it talks about surveys, it talks about avoiding assumptions, obviously, inclusive social events. One of the things we do at York is we have a family barbecue every year, which everybody is encouraged to attend, which takes place mid-afternoon, sort of 4 o'clock in the afternoon. A completely different subset of staff come along to these inclusive social events, to a drinks reception for somebody's retirement taking place in the library at 7:30 in the evening. You see totally different staff members coming along with their kids, playing with one another, and making sure these events are fully inclusive to LGBT families as well. Encouraging a degree of personal expression, I think is quite important. Not simply saying, you're all scientists, we want all of your web pages to fit a standard template that only lists 4 research papers and what conferences you've been to, and there's no scope for personal expression. I think the lack of an ability to express something personal in a formal space is a negative thing, particularly for areas where there's hidden diversity. And things like networks and champions, which we now have in our department, obviously partner benefits. This is a US thing where partner benefits are a big deal in recruiting staff, where you might be looking at benefits for the partner that you want to recruit and making sure they apply to LGBT people as well as people who are married to an opposite sex partner. And the scientific community can do lots, and I think the sponsorship that Beth got for this event shows there's an appetite there at a high level in the scientific community to do things. And she mentioned the 175 Faces of Chemistry, and I'd highlight this as a brilliant thing that the RSC did under the leadership of Leslie Yellowlees, who was really pushing women in science and diversity in science. It looked at putting together on the web 175 faces for its 175th anniversary that should be diverse and reflect the full diversity of what scientists are. And so there were scientists with disabilities, scientists that were LGBT, scientists from ethnic minorities, scientists that were women, across all periods of history, modern era as well. And there's just some brilliant biographies to go and read on there, really inspiring ones. You know, there was a female student in York who came from Mexico, studied in York, and has gone back to work with underprivileged communities in Mexico in some of the poorest areas of the country to try and allow those kids to succeed in science. It's a whole variety of stuff on there. And of course, meetings and networking are really important aspects of what people can do. And events have been going on in the USA for quite some time, and it's really nice to come to an event here in the UK. And I know lots of people are going to offer thanks to Beth for organising it, and her wife, probably more importantly. But I'd like to be the first one to do that and say that actually events like this really are quite important in changing the profile. And so I wanted to finish off with this slide. Really, I wrote an article for Chemistry World, which is really, I gave my first lecture on this topic sort of February 2014, and then very shortly afterwards published this piece in Chemistry World about why it matters, I suppose, why it shouldn't just be a hidden issue, and why we should embrace diversity in science. And we call the article No Sexuality, Please, We're Scientists, because that was the predominant attitude that we got from scientists, was that this was a scientific space, not a space where people wanted to talk about personal lives. I hope that for the reasons that I've outlined, so that young people can feel confident that they can succeed in their careers, that they won't have unconscious bias discriminating against them, so that a global community of LGBT scientists can feel solidarity, working together in science, but being happy to be LGBT. That for all these reasons, it does matter that we're able to talk about sexuality in a scientific space. And that perhaps because it is a hidden diversity issue, unlike women in science or ethnic minorities in science, both of which are enormous problems that require solutions, I don't downplay either of those, but it's very easy to measure things, to get data about women's experiences in science and ethnic minority experiences in science, and you can track how many of their grants get funded and how many of their papers get accepted and so on. For LGBT communities, there's absolutely nothing you can do because it's a hidden diversity issue. There is no way of knowing if there is unconscious bias against scientists who are out. Some of you might feel you've experienced that. You all have your own experiences to bring, and that's one of the reasons an event like this is an important thing. We have no idea because it's a hidden diversity issue, and it's vital that science embraces all aspects of diversity for the reasons put in this quote. And that's because diverse scientists have diverse ideas, and really for science to proceed and progress, we need diversity. And it is happy and fulfilled scientists that will perform better. They will work harder in the lab. They will spend more time solving their problems. They will integrate fully as part of a team if they feel accepted across their whole life, and they're not compartmentalizing a personal life into a separate space, which will pull them away from a kind of integrated enjoyment of the workspace. Because science and engineering very often is a passion for a lot of us. And we do pour a lot of our energies into it. And we'd like to do that in a really supportive environment. And again, I'm sure lots of you will have supportive environments, but some of you may have experienced, let's say, the chilly and heteronormative environments. And if we only care about the science and not the people who are doing the science, then it's my view at least that we won't achieve the best results out of our teams. We won't have that diversity of experience, and we'll be driving some good ideas out of science. So that's really what I wanted to say, and reflect on and sort of get us thinking about as we go into the STEMinar today and look at some really exciting science that people are actually doing. That I think it's important as a community that we can both talk about LGBT issues and talk about scientific issues. I think this meeting is going to be a great example of that. And thank you very much for the invitation and the attention.